All right, I think we'll go ahead and get started here, make sure we don't run out of time. So this is Software Economics. I am Joe Short, Principal Consultant at Feature 23. First and foremost, thank you all for attending. I expected maybe 10 people here. I thought this would be a little bit of a boring topic, so I appreciate everyone's interest, especially people in the front row, thank you. How's the conference, first day of the conference going for everyone? Enjoying yourselves, learning some stuff? Awesome. Yeah, it's awesome to have this back after 3 years. I just want to give a special shout out to Paul Irwin on this. I've worked with Paul for the past 8 years now, and I know how much effort he and Katie put into this and everyone else. So just, thank you, Paul, when you listen on YouTube. All right, so this is going to be more of a conversation, less of a presentation. So feel free to raise your hand, ask questions, interject, snide remarks, all fine. Before we get started, just so I have an idea of who I'm talking to, how many people in here are engineers, QA, designers, like you write or test code for your main job? Awesome, sweet, this is geared for y'all really. How about project managers, product owners, things along those lines, executives? Handful, cool. And what about recruiters? There she is. No worries. All right. So, Joe, so a little about me before we get into this. So my education is actually not in computer science. I was a computer science major at Baylor University until 2001 when the dot-com bust happened and everyone said that all the engineering jobs would be outsourced to all overseas. And so I foolishly listened to that and dropped out of that and I majored in finance instead. And then I went back later and got my MBA as well. So my education really lies more in the business side, although I've been a full stack engineer for the past 11 years now. So why did I get into the industry? Of course, it's because I'm God of the machine, right? It's the ego complex. You make the machine do what you want and everything like that, right? Which is awesome. But it's not only that. This is a question our CEO, Mike Potts, asks to everyone all the time. Why did you choose to devote a significant portion of your life to this industry when you could have done so many other things? It took me a while to think of the answer to that question, and it finally hit me. And it sounds a little grandiose, so apologies for hyperbolizing, but I truly believe that engineering and computing lie at the intersection of virtually all human knowledge accumulated to date. So obviously we got STEM subjects, right? So we also got art, we've got history, we've got language, we've got probably some other things I'm not even thinking of right now. But one of the big ones for me was actually philosophy. Philosophy and code seemed like kind of a weird thing, right? Well, it is. I'm going to show you how. So Plato's theory of forms. Who's familiar with Plato's theory of forms? Wow. Okay, cool. I get to teach this. All right. So basically, in a very high level nutshell, Plato says that, as an example, on the real world, there is no such thing as a perfect square. You can examine it, and you will eventually find a flaw in it. The form of a square is a perfect ideal that will never exist in the real world. What does this have to do with software, right? Well, I found software hits 3 phases. The first one is the software we plan to build. The second is the software we actually built. And the third is the software that we should have built. Now, ideally, you want to maximize that area. That means you got happy customers. When that area is kind of small or non-existent, then you may have some problems on your hands. So what we'll cover today, engineering business value. That's a phrase we're starting to use at Feature 23 a lot, which I'll kind of get into in a second. We're going to have to go over just a little bit of business theory. It'll take 10-minute stops, I promise. It won't be too painful. And then maturity models in both the forms of architecture and quality. And then we'll lastly cover failing projects and how we can help A, avoid those, and B, what to do if it happens. Why does this matter? Well, I'm, again, stoked that so many people in here feel that this topic matters. Here's why I thought it should matter. Number one, we are all in the business model business. I can't say every single, most of us here probably get paid for our efforts for writing software, right? Well, that means you're in the business model business. Whether you're working for a for-profit, you're working for a government, a nonprofit, or if you're a freelancer. You are in the business model business already, so it's important to understand that. Secondly, we are all responsible for cost, every single one of us. Every decision you make at work influences the cost of the software you're building. And thirdly, we are all at least partially responsible for project success or failure, every single one of us. And 4, we are all accountable, which we'll cover in a bit. So I felt the best way to do this would be to kind of take us down a path. We have a potential new project called Widget X. It's going to make us smarter, better looking, make food taste better, et cetera. So along the way, we're going to use this as an opportunity to stand on the shoulders of some giants in both the business world and in the engineering world. So lots of people way smarter than I am, or who we're talking about here. I've just kind of combined it into information that hopefully makes sense. So also, as far as terms, anytime I say we, I mean us, we're building the product together. They or them, that's the customer who needs the product, just for nomenclature. All right. Every customer loves to ask, how much is it going to take, or how much is it going to cost, and how long is it going to take? Here are some common answers to that question. These answers are not professional. You cannot say it costs what it costs or it takes what it takes. So, how do we help this customer? So let's define customer real quick, it's important. A customer is whoever is paying for the project. This could be an actual customer of yours, or if you're working for an internal team, it could be the team internally that is paying for it. So like if you're working at Availity, say, I just happen to know some people who work there, then your customer is the business side who's paying for the IT side to build the product, right? So we have 3 questions we need to ask each other before we even start thinking about this. The first one is, should we build widget X? First and foremost, is the product ethical? Going to the ACM Code of Ethics, we have 3 points to hit. It's kind of like the 3 laws of robotics in a way. It should contribute to society, it should avoid harm, and it should respect privacy. If we can't assure those 3 things, then we should not build the project. Now, this is actually really important because engineers themselves are being held accountable for this, just like doctors and attorneys and accountants are. Back in 2019, the keynote here for Code on the Beach, one of the keynotes I should say, our CEO Mike Potts gave an awesome speech, Architecture in the Age of Accountability. There's a QR code there if you want to scan it for bookmarking or something like that. And then it says, what if your career actually depended on the success of your project? And it's an interesting question, right? Anyone QR yet?
It's a good one.
So, gotcha, for anyone that did. It was Rickroll. This is the real QR code, I promise. So if anyone wants it. All right, second one is, can we build it, widget X? Again, going back to the ACM, we should only perform work in our areas of competence. If we don't know how to build this product, we shouldn't agree to build it. Maybe we could take some steps to get that knowledge, but at the very outset, we should not agree to it. So, going to a little theory here. There's an engineering professor at the University of Texas at Austin named Billy Cohen, who wrote an amazing yet very thick-readed book, Discussion of the Method. He's a mechanical engineer, but it very much applies to software as well. He comes up with a few terms that are actually pretty awesome. The first one is state-of-the-art, or SOTA. We often hear this defined as a state-of-the-art stereo system or something like that, adjective, right? Well, he uses it as a noun, and he defines it as the heuristics used by a specific engineer to solve a specific problem at a specific time. So it's time-bound, and it's person-bound. I would extend that a little bit to be, and not only the individual, we also have team SOTAs. For instance, if you're asked to build a mobile app and you have no mobile experience on the team, why would you start building it, right? Organizationally, if your organization has no experience building fintech, because there's a lot of regulation and security that goes into that, you shouldn't be doing that because you're opening the client up to potential problems later on and potentially yourselves. Then there's the industry. If someone wants a time travel app, we should probably respectfully decline that project, right? The other term in here is the term heuristic. So heuristic is the engineering term for rule of thumb. One of my favorite, just has nothing to do with this, it's just my favorite things in his book. The heuristic he uses when people ask how much is it going to cost to build a particular building, he says what you do is, the heuristic in engineering is you figure out how much concrete you need, and you multiply that by the cost of ground beef per pound. There's a correlation there for some reason. Now, if you want it to be a real fancy building, then you use sirloin instead of ground beef. I just love that one. So main thing is, if it's not in our SOTA, we can't work on it ethically. Thirdly, this is one that we have, as a principal consultant, I have to ask this question to our clients all the time. Should you, the client, build widget X? There's 3 reasons we should build widget X. there's got to be return on investment for it, right? The first one is if it's in your value proposition. This is what you do as a company. If you're building a social media platform, gaming, AV editing software, this is what we do, this is what we sell. Got it. Second would be operational efficiency. These are your standard line of business apps, inventory, accounting, et cetera. And third would be customer experience. These are things just to improve customer engagement, like websites for restaurants and online shopping and things along those lines. In consulting, we often get proposed projects that we call vanity projects. They're projects that someone really wants to build and they have no real business reason for doing so. Even if it's your money, we have a responsibility to say no to that. And I'm sure people who build internally probably have similar stories from business execs asking for the same thing. All right, so where we're at? Go good, we're in good time here. All right, so next up, business theory for engineers. Again, it's gonna be brief. First off, Peter Drucker. Peter was the father of management thinking. He spent his entire life researching the concept of the theory of the business. He says that you think you can create something that people will buy. Once you do that, you're on the clock. Because eventually someone's gonna catch you or the market's gonna change and that product or service will no longer be needed. So once you actually so you go from a hypothesis of what someone could buy to a theory that we think people will buy this. And then once you're there, executives, this is why CEOs have jobs, board of directors have jobs, they need to start working on the next line of revenue for the next X number of months or years or something along those lines. If you don't find the next theory, then your business will die eventually. I think Microsoft is the best example of this. We started with Windows. Now we have Office, Xbox, Azure, et cetera. All kinds of different areas that they've been investing in. So that's obviously a lot of work to do all that. So how can we build this as cheaply and quickly as possible? Next up, we have the 3 horizons model. This one's not too hard to follow. This was developed by McKinsey consulting firm in 2000. The first horizon is short-term innovation to organizations' existing business model and core capabilities. These are things like operational efficiencies, improve user experience that are really focused kind of like a 3 to 6 month kind of time frame. These are our immediate things we need to do. After that's Horizon 2, which would more be like, actually I'm sorry, the first horizon was like 1 to 3 years. How it was originally defined, we'll modify that in a second though. Horizon 2 is extending the existing model. So things like getting into new customers, getting into new markets, complementary products, et cetera. Those are more like kind of 3 to 5 year range originally. And the third is the thing we all love to do, disruption. These are the things that actually create new markets or disrupt existing markets. Uber, SpaceX, Tesla, things like that. These are things that didn't exist before, but then someone created them and now there's a market for them. Now, the timeline has probably been shortened off of that thanks to modern technology advances. Like it didn't take Uber 10 years to create Uber, right? So the timelines are shrinking and they shrink. As time goes on, the timelines are shrinking. And then lastly, startups. We all love startups. Everyone loves the garage origin stories, et cetera. We can do this safely though. Now, startups can be both brand new businesses or brand new ideas within existing businesses. We treat them the same. There are 2 awesome books on this topic. The first one by Bob Dorff and Steve Blank was the Startup Owner's Manual. This is one that's really designed, if you want to create your own startup, read this book. It gives you not only the engineering aspect, but also business aspect, all the things to do, checklist, all that kind of stuff. And the Lean Startup by Eric Ries, even though it was published beforehand, it actually takes ideas from the Startup Owner's Manual from way back before it was published. This covers, how do I phrase this? This covers the kind of concept of starting small and then growing into an appropriately scaled business model. Now, so what we want to do when we have these new theories, going back to Drucker, is how can we prove that these things actually exist? Before we spend millions and millions of dollars on a product with no customers, how can we prove them? Well, the first thing would be just a proof of concept. Proof of concept is designed to prove that someone actually wants this. There's a market for it. After that would be a prototype, a functional prototype of core capabilities that you could actually deploy and get customers to pay for. After that would be the minimum viable product, which would be the minimum set of features that you could actually run the business around. And then eventually you'd have a 1.0 release, which is the fully weaponized, awesome, has the bells and whistles, all that kind of stuff. So, who in here is familiar with the story, origin story of Zappos.com? We have 1, 2, 3. Awesome. So fact check me. There's one thing I couldn't find in sites. So fact check me if I'm off on something here. Zappos.com was founded off of a theory, of a hypothesis, I should say, that people would buy shoes online. And so instead of building out the entire platform immediately, one of the founders spent, I believe it was $6,000. He bought a camera and a very cheap marketing site. And he went to all these different stores and he asked them, can I take pictures of your shoes? And then I'm going to post them on my site. When people buy them, I'm going to come back to your store and I'm going to buy them for you at full price and then ship them on. The store said yes, easily done. He took that idea, proved his theory, and created a business that he then sold to Amazon for $1.2 billion off of a roughly $6,000 startup cost. That's how you do it. Let's see. Okay, we're good. Questions thus far? We're a little ahead of pace here.
So that one slide that talked about the three horizons,
Yep.
simultaneous, or are you saying like different businesses might take one of those?
Mature business focus on all three at the same time. It's kind of like how executives split their time, or actually all employees. So most of your kind of line level employees are going to be focused mainly on Horizon 1. And as you go kind of up the hierarchy, you're going to start focusing more on Horizons 2 and 3. Good question. Good? Sweet. All right, so now that we got through that, it's time to start planning out building this. We have validated that it's going to make the world a better place after all. Also, we're not going to take out the vowels we suggested earlier. So we're armed with some extra information, right? So let's get dangerous with it. First of all, everyone cares about software cost, or at least they should. Now, often, the accuracy of your estimates is more important than the amount of your estimates. The executives in this room can tell you why that is. It's for budgeting. It is better to say something is $500,000 and have it be $500,000 than to say it's $300,000 and have it be $400,000. It is way easier to get those funds. Normally, they can get the funds that are needed to fund a project, but it's hard to go back and ask for more money towards the end of a project. In consulting, cost is always front and center on us. We're constantly hammered on this. For some reason, we have noticed that for internal projects, that doesn't seem to be as big of a focus. Oh, we'll just have the IT team do that. No problem, right? Well, it still really should be, because of the concept of opportunity cost. If you have your engineers working on something that isn't as profitable, you're not having them work on something that could be profitable, right? This should be an absolute check in decision-making process. Now, in the accounting world, most labor is considered a fixed cost because it's hard to hire new people and let people go and all that kind of stuff. So accountants tend to not care about it. Even if they don't care about it, we should absolutely care about it as far as engineers go and executives. Awesome book on this topic is Out of the Crisis by Edwards Deming, written in 1982. One of the best quotes he has in there is, you cannot talk about cost without talking about quality. You can have a cheap solution that's a cheap solution, or you can have a quality solution that's more expensive. Let's take a look at this a little more in depth. Who's seen this chart before? Awesome. So, fast, cheap, good, pick two. The third one does not exist. No, excuse me, the intersection with all three does not exist. Now, you can argue, I can build things fast and cheap and good. Yes, but it doesn't exist relative to your team's performance. So you can have a very high functioning team that can still build it cheaper than everyone else, but you could always build it faster if you didn't have to build a higher quality solution, which you may not always need. So cheap and fast, not good. Fast and good is expensive. Good and cheap, not fast. Now, knowing what we know now about POCs, prototypes, MVPs, and 1.0, I'm hoping you can start to see where these kind of start aligning. For a POC, we want it to be cheap and fast. We want to prove the idea as quickly as we can. We're going to throw that code away in all likelihood. We don't need design patterns in there and things along those lines. Get it done, prove it, and then true or false, and then move on. For a prototype, probably the same thing, honestly. You don't really need high quality code off of there because we're still working on it. Once we get to MVP, let's start talking about that a little bit. 1.0 level, we have to start protecting the business because we're actually generating revenue now or cost or whatever. So we need to actually begin, start really thinking about quality at that point. Software cost. So this paper is by Stanford professor Geo Wiederhold in 2006. What is your software worth? He looked at 30 years of data for his model. It's not predictive, it's just a historical model. And he came up with that the total cost of a project is 3 to 5 times higher than the initial build over a 10 to 12 year period. This should be a scary number for a lot of people. So if you're saying something is $500,000, you're really telling me that's $2.5 million over a 12-year period potentially? Yes, 100%. Now, that's actually good money to spend. If you're still spending that in 12 years, you had a very successful product, right? Now, I will say at Feature, we have found that for web projects nowadays, for our projects, the cost is about 1 to 2 times. Mobile is still about 3 to 5 times. Mobile is definitely the most expensive space to build in. And then, obviously, we want to keep this on the lower end, of course. And then, executives do get nervous with big numbers without certainty. For the executives in the room, if I told you that's going to be $2.5 million, who's going to rush to sign up for it immediately, right? So, what can we do to lower the risk here? What we want to do is validate the economic model. So before we do that, let's talk architecture. If you're not familiar with Martin Fowler, I highly suggest that you should be. He's the chief scientist at ThoughtWorks. He has written tons of books, awesome blog. He's kind of the luminary in the engineering field as far as citing people. So when in doubt, I promise Martin Fowler wrote something about it. In fact, my other presentation I did here in 2018 on presentation model was from Fowler as well. So. But he and Ralph Johnson, who's one of the Gang of Four from the original Design Patterns book, had an email exchange in 2003. It's online, you can go find it. It says, what is architecture? And the very precise definition we got from them is system design. The important stuff, whatever that means, that is an exact quote. Things are expensive to change, and the decisions that you wish that you got right but didn't. These two brilliant guys, this is the best they came up with on this one. It kind of reminds me of the Supreme Court Justice Potter Stewart in 1964. Won't go into the topic, but he says something along the lines of, I know it when I see it. Very similar kind of thing when it comes to architecture. So what we want to do then is we want to do what we can to make sure we get these decisions right the first time. But how do we know that? We don't actually know what this product is going to be yet, right? So another very brilliant architect named Gregor Hoppe in 2017 wrote this white paper, Architect Elevator. And so what he proposed was to buy information now to save money later. And he could never get executives to understand this. Why would I spend money now and then have to go spend even more money later on? Why wouldn't I spend it all, just tell me what it's going to cost? Because we don't know exactly what it's going to cost yet. We need to figure that out. So he had a brilliant revelation. He phrased that conversation into options theory. Once he explained that it was basically like trading options to executives, they're like, got it, totally understood, proceed. So this enables us to validate the architecture early in the project to hopefully reduce or avoid the things that are expensive to change later on. All right, finally, we're getting ready to build Widget X. All right, our first step here would be a proof of concept. Going back to Drucker, right now we have a hypothesis around a potential business. So let's validate that with a proof of concept. The proof of concept is throwaway code. We want to validate that there's a market for this product or a particular feature or whatever. This is hypothesis stage, also kind of correlates to stage 3, back to the 3 horizons model. We want to show that something is technically feasible as well, i.e. the architecture and also integrations. Who here has worked on a project where the integrations with third-party systems ended up being the most complicated part of it? Should be most hands in the room, yeah. If you've been doing this for even a couple of years, yeah, that's one of the biggest ones. So we do POCs for integrations all the time. In fact, for our projects as a principal consultant, what I do with my clients is I say, all right, before we even start building this, we're going to set aside X hours to do a POC on your integrations. And in fact, we have a client right now where they said, oh, we have a very well-documented ERP, and it should be fine. Yeah, it is, but it doesn't give us the methods we need, so we have to do all this kind of work around it, so we can now revise our estimates on what things are going to cost. And then also the heuristics we probably want to focus on here for POC: fast and cheap, low code quality, load testing. I wouldn't recommend putting a bunch of design patterns or abstractions or wrapping libraries or anything like that at this stage. This is the kind of stage to just get something done, see if it works. All right, after that, we have our prototype stage. This means that hopefully, we had a successful POC. So the hypothesis was proven successful, so now it becomes a theory, right? So this is still probably in stage 3 of the Horizons model where we're kind of at now. Prototype, as we said earlier, build a subset of the core features that are needed for the application. We're buying knowledge, reducing risk. At this point, we're not worried about profit or cost savings if it's a cost-saving product. All we're worried about is sales if we're trying to sell it, or adoption, just making sure this theory actually holds water, survives contact with the end users, all that kind of good stuff. Now, at this stage, we do need a little bit higher level of quality to protect the business. Security vulnerabilities, especially for like an internal application, or actually even external as well, now that I think about it. No crashes, things like that. Protect the company reputation, make sure no one gets hacked, all that good stuff. And then this is also the stage where we can work on improving our SOTA. If there's something in here that we don't know how to do, this is the area where we can learn how to do it without risking the overall project. We can do this as POC and prototype. Really what we're trying to do is we're trying to figure out what might influence or risk our plan. And if we find something significant, then we can then create a new plan off of it. It is potentially more expensive to do it this way, but it reduces the risk overall because it gives very easy eject options for the business side. Next up, we have MVP. This is the minimum set of features to launch. Now we're kind of crossing from stage 3 to stage 2. I'm assuming most people here know the phrase MVP, right? Perfect. This is an area where we probably need to have a little bit better code quality. This is the time to start talking about doing the things like reusable libraries, things along those lines. Now, there is one concept we haven't touched on yet, which is technical debt. Technical debt is often seen as a bad word in our industry. Who likes technical debt? I do. I love technical debt. You know why? Because I can get there faster and I can prove things out more quickly. I explain this to our customers just like I would with a credit card debt. We can take on debt now and get this launched faster and cheaper, and if it works, then we'll have the money to pay it off later. So, how many of you have made decisions, like I know I have as well, how many of you had made decisions to not take on technical debt when maybe we could have in order to get something done a little more quickly? Right. And in these cases, it's better to, in fact, people on my team can attest to this. I've talked with our product owners and said, hey, this is how we should do this, but we could do this. Like, yeah, do that instead. It's fine. We'll pay for it later. No problem. All right. What's missing? What haven't we talked about thus far? This seems like a pretty good check-in area. Microservices. We have not talked about microservices yet, and this will be the only time we do during this presentation. Now, I am not knocking microservices in the least. Who has ideas on when we should consider a microservices architecture?
Only when necessary. When the program gets too big and it needs to be broken out.
Okay. Scale? Okay.
When you're running into scale issues.
Okay. Yeah, that's the answer I was looking for. Perfect. So all those answers are valid. One of the answers that is very rarely cited, I'm honestly impressed that someone has cited this one, is that organizations, microservices are often more about the organization that you're working in versus the technology that you need to build with. There's a concept called Conway's Law. This sounds really, really esoteric, but I'll give a concrete example of it. I just want to get the quote right. This was came up by a researcher named Mel Conway in 1967, going back a minute here. Conway's Law is any organization that designs a system defined broadly will produce a design or architecture whose structure is a copy of the organization's communication structure. That's really abstract, right? So how many of you work in firms where you have like a front-end team and a back-end team? Couple? Okay, perfect. I'm willing to bet that most of your products end up being designed by contract through the APIs. Perfect example right there. So if that's how your team is organized, then that's how you're going to build. How many of you have DBAs on staff or work with regularly? How many stored procedures do y'all write are written for you? See? Not enough. Good answer. Good answer. So different teams, if they have different structures and different organizations, are going to still solve the same problem. They're just going to do so differently. So microservices, in my opinion, is more an organizational conversation than a technology question. We also haven't talked about distributed computing. Who knows Martin Fowler's first law of distributed computing? Don't distribute. That's his first law. Not to knock the distributed presentation we had earlier in the day, but there is a reason for it. My now former team at Feature, we did a research project this past year, actually we did our lunch and learn like in March, I think it was, on microservices and .NET. And the team was super excited to do it. And then when they got into it, they're like, man, this is hard. It's really hard to diagnose what's going on. It's really hard to debug what's happening here. Yeah, all that costs a lot of money too, especially when you're doing it in production. So again, there are times and places for these things, but they're not necessarily at the outset of a project. Fred Brooks, who we'll cover in a second, who wrote Mythical Man Month, for those who are familiar with that book, he has an awesome essay in that one called No Silver Bullet. There is no one architecture to rule them all. We also haven't talked much about code quality. For anyone not familiar with the design patterns, there are two books in here that are kind of the key ones in my opinion. The first one, Design Patterns, the 1994 one, The Gang of Four. That's more of a reference book. I wouldn't read that to learn design patterns necessarily. The second one is what we give all of our candidate engineers when they start, which is Head First Design Patterns. That was written in 2004. New version came out a year or two ago. And this is a very practical guide on like how to and when to implement some of the more common design patterns for anyone who wants to go down there. We also haven't really touched on unit testing, TDD, generics, wrappers, all that stuff. I'm not going to go down the TDD rabbit hole. I don't feel like having that conversation today. But again, no silver bullet, right? We'll get to those things when it makes sense to. And then, let's see here. Also, the other thing we haven't done is testing methods. So, how many people who knows the joke about the QA person walks into a bar? A few people? All right. So for those who don't, a QA person walks into the bar, they order 1 beer, they order 20 beers, they order 1,000,000 beers, they order negative 53 beers, they order B beers. That's called fuzz testing. So in certain projects along this, wherever the maturity model is, we've had a QA analyst who was amazing at that. I don't need that on a prototype though. I just need to get it launched. We realized later that she didn't have a good grasp of the code quality that the project absolutely needed, so we created we logged a bunch of needless bugs that we then had to spend time going to fix that added zero value to anyone, because in these particular applications, no one would have done that. And then also tools. Everyone knows about the library of the week, the different IDEs and everything, CI/CD. Ooh, who wants a fun story? Who uses YAML pipelines for doing builds, like in Azure DevOps or whatever? A handful, cool. When you first started out, how many of you made sure your YAML pipelines worked in a fully automated CI/CD setup using Git flow branching strategy? Guess who accidentally deployed it to production because he didn't do that? Now, fortunately, there was an approval stage, so I was able to catch it. So as an example, when we were doing a big project, that's when YAML pipelines came out. This is what I'm supposed to do, right? So let's go do YAML pipelines. In hindsight, what I would have done was a POC using the exact branching strategy that we were using, even just to deploy one file or something like that. Instead, everything worked just fine until after our first deployment to production. Once we merged domain, everything was fine. The next time we did something on develop, though, it tried to trigger deployment to production because the YAML file was set up to trigger that based off commits to the develop branch. So little gotchas like that are everywhere. And for those of you who have had to deal with this kind of stuff before, it's expensive, it's time consuming. These are things that put projects at risk. And I guarantee you, if you asked a product owner or an executive, or if you had to go to tell them and they said, well, we wanted to change our build pipelines. Well, I would ask, was the existing one already working? Yeah. So why did you change it? article said I should. Like, it's hard to have a good answer at that point, right?
Hype-driven development.
Exactly, hype-driven development. Love that. All right. And the tools we just covered. All right, perfect. All right, so lastly, our MVP was a success. We're at 1.0 now. Now's the time to start weaponizing our product. Let's start talking automation testing. Let's talk about Netflix Chaos Monkey. Let's talk about recovery plans. This is all the big stuff we need. We have people who are relying on this product, internal, external people, and also this product can now hopefully pay for itself, whether it's in revenue or cost reduction. But we have to now protect our product and protect our business at this point. This is the time to actually do all those things that we read about that sound awesome to work on. This is the time to kind of do those when the project necessitates it, not at that absolute beginning if we don't even know that this project's going to be successful. Now, hopefully at this point, it would be time to analyze this. Going back to this chart, what did we plan, what did we build, and what should we have built? And hopefully we're getting a little bit closer to maximizing that middle area. Now, it's always better to avoid this. Hopefully, the steps we've taken so far have helped avoid this. Who here has had a project go off the rails? Yeah, come on, get more hands up. All right. Projects go off the rails all the time. What I've found is that this really kind of helps to keep your product owner on track by kind of focusing on these kinds of questions. So how can we possibly avoid this happening? We have 3 questions we ask ourselves at Feature. Whether it's for a new product or for a feature within a product or just a regular user story, whatever. Why am I writing this? What business value am I adding by actually doing this? And if engineers are not able to answer that question, then they're not allowed to work on the story. It's that easy. What is the expected code quality level? Do I need to have unit tests around this? Do I need to TDD this? Or do I just need to get this done? Third, how will I know that I did a good job? This one was a place our CEO had worked at, an engineer he was working with asked this question. It was one of the most brilliant questions I've ever heard. When I'm done with this story, how will I know I did it correctly? Well, if you have solid business requirements and you have solid engineering requirements, I call it the answers to the test. Your story should have the answers to the test here. That way, when you're done working, you can say, yep, it does this, 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 I didn't do that, perfect, we're good to go, right? If you can ask those 3 questions before starting work on a new project or new story or something, you're gonna help your product owner out a lot. And what I've found as a lead engineer and as a principal now is that engineers on the team catch this stuff way faster than I do, way more efficiently, because they know the ins and outs of it, right? No product owner, no consultant or anything can think of all these things ahead of time. Now, when we do have a failing project, what do? First and foremost, let's reassess. One thing we've noticed is that sometimes projects are considered to be failing projects based off flawed metrics. Going back to our Venn diagram of software we should have built versus what we actually built. In Agile, the whole concept of Agile is to code to discover requirements, right? Well, along the way, we may discover that our requirements were wrong all along, which is fine. That's what it's designed to do. But if you're still measuring based off the original estimate off of that, then you're not comparing apples to apples anymore, right? This is what we planned. This is the product we ended up needing to build. So it's not that our estimate was off. Our requirements were wrong, right? And so, stop, reassess. Was it process? I've seen too many projects that have failed because of process-related reasons, and maybe not the reasons you're thinking of. So, as an example, I've seen projects where, in true Scrum fashion, the entire development team was on every single meeting because that's Scrum. Well, when it happened is they're spending 3/4 of their time in meetings and only 1/4 of their time writing code. Now, as a consultant, we were able to show, through numbers, hey, here's how much you're paying us to do this. Do you really want us to do this? And no, we don't want you doing that anymore. But again, internal teams didn't really have that opportunity, right? Now, there are also times that being on time and on budget is more important than building the right software. That sounds really wrong. It feels a little dirty. But sometimes there are contractual obligations. We had a client 2 years ago, I think, was in this situation where they very clearly said, we don't care if it's the wrong product. We have a contractual obligation to get this product built as designed. Do it, we'll revise it later on. Cool, no problem. That's the business's decision to make, not the engineers, right? Also, for those who are not familiar, who's read Mythical Man Month? Awesome. This is one of the ones that we've kind of put on our core reading list as well, so I definitely recommend it. It was written a while ago, 1975. There are definitely some essays in there that probably aren't as relevant anymore, but the titular essay, Mythical Man Month, basically says Brooks' Law, which is that if you have a project that is late, putting additional resources on it will invariably make it later. And we see this happen all the time. Reason for that would be because you're taking experienced people who could be delivering value on the project, but they're having to stop and catch other people up, go back and fix issues, things along those lines. Easy analogy is that if it takes 40 minutes to bake a cake at 350 degrees, you cannot do it in 20 minutes at 700 degrees. Some things just take the time that they take, right? Then lastly, we get to the sunset phase. All projects end. Now, hopefully, again, 10 to 12 year horizon nowadays is considered a successful project. You know, it's been a great run. We had a great project with WidgetX. The main thing to do at this stage is to protect the business. You know, we can't just abandon the project and abandon the users. Then you have transition plans, you know, migration to new systems, whatever the case may be. And then hopefully we're preparing for the next product as we're starting to prove the next theory of the business, a la Drucker. Takeaways. Here's what I hope we got out of this. See how well we did. First and foremost, our mantra at Feature is this and always this. Business value or engineering value should never exceed business value. So thinking back, that sounds kind of odd, but thinking back on our POC concept. If someone told me that they TDD'd 100% code coverage on a POC, I'd have a problem with that unless your POC was, can I TDD this with 100% code coverage? So as engineers, as long as we understand the questions to ask, we can usually get really good answers on these and find really good ways to move forward. Number two, related, choose the appropriate level of complexity. Not all projects necessarily need to have perfect code quality. We can build perfect code. It costs a lot more money than most clients are willing to spend. Now, that being said, sometimes we do have clients that say, yes, even though we're just starting out, we need this to be exactly perfect code quality. Fine, as long as you accept the cost for that. Thirdly, work within our SOTAs, state of the art. If we are working outside of our state of the art, this is where we as engineers, as professionals, put the entire organization at risk. Because we cannot confidently say, A, that we know how to do this at all, B, that we'll be able to do it on time, on budget, and C, that we won't expose significant issues later on, whether they're legal, security, things along those lines. Now, there are ways to build the SOTA ahead of time, so we can't, you don't have to say no to everything, right? But you know, we shouldn't start onto it immediately like that. And then lastly, hopefully we can minimize the difference between the software we planned, built, and should have built. Any questions? End of prepared remarks. Nobody? All right, well, thank you all very much for coming. Enjoy the rest of the conference.